Hello everybody. In our last video, we learned the importance of math in the world of data science. And as I stated earlier, statistics is your first stop while working with data in your company. Today, we'll start looking for the major concepts of statistics which are relevant for data science industry. I will be covering all topics of statistics from basic to advanced, doing hands-on practice with real-world datasets in my upcoming videos. I hope you follow the thread of this series and stay tuned for all upcoming videos on statistics. In our today's video, we'll try to learn what is statistics, what are the different types of statistics, measures of central tendency, that is, what is mean, median and mode. We'll also look for measures of dispersion, that is the spread of data, focusing on range, variance and standard deviation. We'll be learning the famous Chebyshev's inequality, which talks about the proportion of measurements that lie within 2 and 3 standard deviations of the mean. And finally, we'll look for measures of shape in which we'll learn skewness and kurtosis of data. So, what are we waiting for? Let's get started. So, when we talk of statistics, what does it first comes to your mind? I've taken a dictionary definition of statistics which states, statistics is the science that deals with the collection, classification, analysis and interpretation of numerical facts or data. And that, by use of mathematical theories of probability, imposes order and regularity on aggregates of more or less disparate elements. Now, when we see this mouthful definition, let's divide it in two parts. The first part talks about collection, classification, analysis, and interpretation of numerical facts or data, which we all know or call it as descriptive or summary data. The second part talks about use of mathematical theories of probability, imposing order and regularity on aggregates of data. This is nothing but the inferential statistics. We infer meaningful patterns imposing order and regularity on the data. We will be focusing more on inferential stats as it is very important in our future videos. But for now, seeing this definition, we can say that statistics is broadly divided into two types: descriptive or summary statistics and inferential statistics. When we talk of descriptive statistics, what does it come to your mind? Imagine you are a big fan of cricket and you are interested in understanding the batting performance of a cricket team in a recent tournament. You have collected data on the total runs scored by each player. Using descriptive statistics, you can analyze this data to gain insights and summarize the batting performance of the team. Looking at the data, you can tell who batted well and who scored less. What was the average run scored by the players? Who clocked the maximum 6s and 4s? And whose strike rate was high? This all is nothing but descriptive statistics. With the data in hand, we can draw many insights from it. Another example, if we talk, let me ask you, what is the population of India? We can describe that the population of India is so and so billion. What is that? It is nothing but a statistic. Another statistic which we can use to describe the population is the population density. Few major cities have high population than other cities. Or we can talk of literacy rate, the median age. All this is nothing but descriptive statistics. We are summarizing the data in a meaningful and relevant way. In descriptive stats, people often talk about mean, median and mode for describing data. Let's see this example. following, we have a data series of 12 data points: 8, 5, 9, 18, 24, 38, 5, 25, 10, 9, 18, 18. If we sum all these data points, we get the total number of values in this series. Mean is nothing but the average of all data points. To find the average, we sum all the data points first and then divide it with the total number of data points. Here we have 12 data points, so adding all these 12 data points, we get a sum of 187, which when divided by 12, we get 15.58 as the mean. Median is nothing but a middle value of sorted data. First we sort the data in ascending order and then we find the middle value. If the dataset has even numbers in it, we take two middle numbers and then divide it by 2 to get the median. Mode is the most commonly occurring value in the dataset. So here we have 18, which occurred the highest time. So the mode here is 18. Minimum is self-explanatory, the minimum or the lowest value of the dataset. Same goes with the maximum. This is the highest value in the dataset. Here we have 38 as the highest value in our dataset. These are some of the basic descriptive stats, which are also called as measures of central tendency. Now, when we look at the above series, what can you say about it? We can say that the minimum is 5, maximum is 38 and the average is 15.58. This gives us a proper understanding as how the dataset is. Seeing the above sentence, can you picture how the data must be? We can say that having an average of 15.58 and minimum of 15, it is highly likely that the most of the data points lie between 5 to 15. The easiest way to visualize the data is by doing a frequency distribution. Frequency distribution is nothing but the count plot of each data point. So in our last data series, 5 has occurred 2 times, 8 occurred 1 time, and so on. Doing a frequency plot, it is very easy to see the distribution of the data, which can eventually help us draw some conclusions. Another way to visualize the data is to bucket the data into intervals, meaning creating bins of the data points. In our example, we created a bin of 5 data points, starting from 5 to 10, 11 to 15, 16 to 20, and so on. Placing the data points in bins can help us understand the data distribution better and in a more convenient way. Many people also plot a line on this bar chart so as to see the curve of the distribution. So, all this we have seen is descriptive statistics. Now, we'll turn towards our second topic, measures of dispersion. Measures of dispersion is a statistical measure that tells us how much data in our distribution varies and deviates from its central tendency. Some of the most used measures are range. Range is nothing but the difference between the largest and smallest value in our dataset. Now, when we talk of range, people also talk about interquartile range. If we see the chart, the median is the center of data and it is divided into 25th percentile, the first quartile, and 75th percentile, that is the third quartile of the range. Interquartile range is nothing but the difference between the third quartile and the first quartile. We often see our marks getting in percentile these days. It's the very common practice these days. But apart from range, there are other 2 measures of dispersion which are important and are used by many companies. Variance and standard deviation. Variance is the average of squared differences of each data point from the mean of a dataset. Here in this table, if we see, we have got a user data of average YouTube usage done by them monthly. So to calculate the variance in this dataset, we first calculate the average GB spent by all these users on YouTube. When we sum it up, it turns around 73.6 GB. When we subtract each data point with the mean, we get x minus mu. In the last column, we have squared the differences of each data point from the mean. When we sum these squared differences, we get 335.2 as sum, which when divided by the number of customers, we get the variance as 67.04. Another measure of dispersion, and the one which is widely used, is standard deviation. Standard deviation is nothing but the square root of variance. It simply talks about the distance from the mean of the data points. Standard deviation is commonly used measure of dispersion because it is expressed in the same units as the original data, making it easier to interpret, and it is also useful for assessing the normality of distribution and also for calculating the confidence intervals in statistical analysis. In fact, Chebyshev's inequality or Chebyshev's theorem states that for any given dataset, at least 75% of all these data points fall within 2 standard deviations of the mean, and at least 89% of the data points lie within 3 standard deviations. Chebyshev's inequality gives us a rough idea of the spread of the data points from the mean. It can also help us detect outliers or unusual data points. Chebyshev's inequality works with any given dataset without knowing its shape. This is very important to note. To understand this better, let's look for this example. We are given a dataset of test scores of students with a mean of 75 and standard deviation of 10. So, to calculate the range of dispersion, we do apply Chebyshev's rule. We know our mean is 75 and standard deviation is 10. So for calculating 75%, we get a range of 55 and 95 as our range, and 45 and 105 as our range for 89%. Looking this, we can conclude that at least 75% of test scores fall between 55 and 95. Then comes our last topic for today: measures of shape. Till now, we have looked for measures of central tendency, measures of dispersion for doing descriptive statistics. Measures of shape is another measure to describe the data. One way to measure the shape is to understand the degree of skewness of data. What is skewness? Skewness is nothing but the absence of symmetry. And what symmetry is? Symmetry of shape is where the left side of data distribution is same like the right side of the distribution. If we see this graph, we can clearly say that it has a symmetric distribution, as the left side is the mirror image of the right side. But what happens when we don't have this symmetry in our data distribution? We often see the degree of skewness. So, for a data distribution which is inclined towards left, we call it as a positively skewed data. If we see in this image, the distribution has a long tail to the right. And if the distribution is inclined towards right, we call it as negatively skewed data, which has a long tail to the left. Another measure of shape is called kurtosis. Kurtosis talks about the peakedness of the distribution. So, if we see in the image, the blue line distribution is with high kurtosis, which has highest peak and heavier tails. The black and red distributions have low kurtosis, as it has a kind of flat peak and lighter tails. All in all, we have covered a lot of topics today, from understanding what is statistic, what are its types, the measures of central tendency, measures of dispersion, measures of shape. I hope you liked the video. Please do like, share and subscribe to my channel to get more such videos. With that, I would also like to tell you that in our next video, we'll be doing a hands-on practice of all this we have learned today using Excel. Till then, thanks a lot all of you for showering your support and love. Hope you liked the video. Take care.